Well, Ipos is the Institute for Photonics and Optical Science, and it is a University of Sydney initiative that brings together researchers from the science faculty, from the engineering faculty, and from the broader university community. And combined with our passion for teaching and education, a really exciting opportunity for the University of Sydney and for Australia.
So the concept of Ipos is a very good one. It brings together lots of important fields. It's been recently demonstrated by both science and nature articles that photonics is the great catalyst. In terms of inventing new fields and new branches of science, photonics has this amazing ability to step between fields and make new things happen.
Well, photonics is a fascinating science of harnessing and controlling light for information processing. And it came about really with the invention of the laser and optical fibre technology. And those two inventions allowed for breakthroughs that underpin today's optical communications networks.
When you download a movie over the web, you can only do so because of photonics, because it goes through an optical fibre and it involves light.
Every time there has been a technology which has dramatically changed the way that we communicate, as this immense bandwidth that can be unlocked by fibres within the home or within the office becomes available, and it will really change the way that we interact with each other to allow people to themselves upload lots of material. I mean, that's been one of the really profound changes that's happened. It used to be a case that people would just download a lot of information. Now it's become very sort of proactive for individuals, and they can upload videos through things like YouTube.
Most people aren't really aware of this, but 5 years from now, they're actually literally making predictions that the energy requirements to keep the internet network going is going to take something on the order of 10% of the total energy consumption of Japan. New technology is absolutely critical to avoid these potential future pitfalls.
And we as researchers, I think, have to become more clever in allowing larger amounts of information to be downloaded.
The geography of Australia requires a unique approach to communications, and optical fibre transmission and optical fibre technology has always been world-class. We're in the southern hemisphere, and astronomy and astrophysics has always been strong here, and that has been a catalyst for much of the breakthroughs in photonics that we've seen over recent decades.
So the use of fibres to collect light from space is something which Australians have really mastered. I wanted to find new and interesting ways to bring light through fibres and analysed in the fibre itself. And that was the birth, in a sense, of what we call astrophotonics. When the light comes from the distant universe, you're not just seeing the light from that galaxy. In fact, you get the light from our own atmosphere. Our atmosphere glows at you. And in fact, it's a terrible background source of radiation. So what we learned to do was to filter that light out with a complex photonic device called a fibre Bragg grating. So now we get light from a distant galaxy, and we're able to remove all the extraneous, bogus radiation from the Earth's atmosphere, and we end up with just one simple spectrum of the galaxy itself.
We're trying to use nature as a database for ideas. And we're trying to mine it for designs that might be particularly interesting.
So nature uses many means to either hide or misdirect, and I'm sure cloaking technology will evolve towards many other different objectives and techniques, whether it's to be invisible or whether it's just to misdirect the person who's trying to see you.
Metamaterials can bend light, and in fact, if designed carefully, they can make structures such as aeroplanes invisible completely to radar.
There are a whole lot of techniques which render planes invisible these days, and the people who are looking for the planes actually use detectors which change their frequency very rapidly in the hope that they'll see the planes that way.
The Defence Force is looking to photonics to replace much of its high-speed RF electronics. The last thing you want in your aeroplane wing is expensive, heavy cables that can be replaced potentially by photonics and optical fibre technology.
So there's a whole fascinating technology which is involved between the quest to detect and the quest to be invisible.
5 years ago, if you were talking about that, you'd be in a Harry Potter movie, and now it's on the cusp of being real technology. Personally, I find the most exciting is the biomedical applications. I think we're going to find that there's a lot of really interesting things that are going to be done combining photonics with medicine and curing disease.
We can harness the breakthroughs in photonic technologies, breakthroughs in sources, bright sources, and other technologies to see through human tissue. These are now being deployed in hospitals around the world and are starting to have impact on the health sector.
I mean, what we're really talking about here is discovering new ways of looking inside the human body. The new types of imaging and things we come up with might be as much of a breakthrough as doing MRI or as doing X-rays. But I'm excited to sort of think about what could happen.
The idea of lab on a chip is that we can imagine shrinking a biological laboratory down onto a chip. We can actually shrink down some of the biological control aspects onto a chip the size of my thumbnail. And we can marry that with photonics, and you now have what is referred to as an optofluidic chip. We have optics and we have fluids on the same scale. Indeed, Australia has a large area, and photonics has offered a lot in terms of communication systems, and there's so much more that it can do. We've been researching terabit per second transmission over recent years, and that in principle offers 1,000 times increase in the capacity of a single optical fibre. What could that do for Australia? Well, we can imagine remote surgery for the rural community. That could have a profound effect on Australia's landscape.
Photonics has a real opportunity for making its way into other non-telecommunication areas. And to take one example, looking at bridges. At the moment, every few years with the bridge, you have to weight it up by driving some heavy trucks onto it and looking at the deflection. And by embedding sensor technology, in particular photonic sensor technology, you can constantly monitor what's happening in that bridge. You can immediately detect when there is a failure, when there's a crack occurred and the bridge has become unsafe. So that will have obviously the life-saving benefits. It will have benefits of lowering the cost of maintaining infrastructure, and it should have benefits to local industry in terms of producing those sensor systems, those photonic sensor systems, to go into physical infrastructure like bridges or tall buildings.
I am basically pushing photonics into a whole new regime, covering a much larger wavelength range than we used to have. And I think that will definitely feed back into the industrial side of things as well. So there's a very nice synergy between research in applied science and in where industry is going.
The Masters and the Graduate Diploma are there to prepare people for these new technologies. What we want to prepare people for is to implement those new discoveries that we as researchers at the University of Sydney and around Australia as well have created in the last decade, and which is now ready to be implemented over the next decade. But for that we need engineers, technicians, executives who will be able to understand and implement those technologies.
Really, in terms of the organisation, the opportunity we've got here with this critical mass of researchers and an active local industry is to do something of real significance in Sydney.
Ipos will be a flagship for Australia in photonics and optical physics research.